let's start 5.1. So we're moving on to something new. Basically about sets. My pen works. Basic set concepts. Do you guys remember sets at all? Yeah, set can be anything. It can be a set of any object or people, or a set of different types of chairs, set of different types of numbers. Set can contain, so long as it contains something, it can really be a set. You can also have a set that is empty. So we're going to go over the notation. We're using the different types of sets. So example 1. Might need your help with this because I don't remember geography at all. B is the set of states bordering Texas. So what is around Texas? And what are all the states around it?
Well, we have New Mexico, Louisiana.
Let's see.
I don't know what's north of that.
Mexico, Oklahoma, corner on the side of Arkansas.
Okay, yeah, Arkansas, Louisiana.
Okay.
Yeah, that's always it's Arkansas, it's so small.
Yeah, it's just like, you know, the map, it's like this little corner.
Yeah.
Okay.
Like, I've driven to Louisiana a couple times. I've driven to Missouri, so I go through over to Oklahoma, and then I've driven to California, so I went through Mexico. That's how I do all those. I always forget Arkansas though.
You spell Arkansas. Is it R-A-R-K-A-N?
Arkansas.
In Kansas. Nice. That helps. Louisiana, Arkansas. What else? You said Oklahoma, right?
Oklahoma and then Mexico.
Anything else? Not Colorado, right? Okay. Oklahoma and New Mexico. That's right. Yeah, I guess so. Oh yeah, you can like cut through it, right? You have to. Okay, yeah. Anyway, so this little braces on the set, this is called the roster method. This is one I use the most, like in other math classes or improved classes. Just some braces on the side, and you just list the elements. So B is a set of states bordering Texas. So 1, 2, 3, 4. We have 4 elements inside B. Okay, so that is roster method. Now, if they say set builder notation, then they kind of label this with a variable, and then they write it out. So set builder would be still using braces, but they're going to say X such that X is a state bordering Texas. So like if this was like a math equation, they would put it here, and X would be the variable. But they don't really tell you the elements usually. Like if they would have said B is all the sets, all the numbers between 0 and 10, you say X such that X is, and then you use the inequalities between. But if you use this one, you would write all the numbers like 1, 2, 3. Yeah, all the way till 10. So, but anyway, that's the difference. Roster, list them, set builder kind of generalizes. Okay. So let's do another example where we do both. R is the set. Oops. is the set of integers. You guys remember what integer means? What is an integer? It is a number, but it's a certain type of number. What type of number is it? So R is a set of integers. I can barely read that. Between -2 and 4 inclusively. It's basically the all the whole numbers, but negative and positive, but also 0. So 0, 1, 2, 3, 4 till infinity. 0, -1, -2, -3 till negative infinity. All those are integers. If they say the word inclusively, what does that mean? Do we include the endpoints? Or do we not? Remember how we had the brackets when we did the domains and stuff? Do we put a bracket on this guy or do we not? I'm not sure. Let's look at the definition, right? We can always do that anytime we want. What is the definition of inclusive? So is an inclusive inequality. Okay. Finally, coffee is drinkable. Okay. So if they equal 2, see right there. Ignore these weird ads. Inclusively. So an inclusive inequality. So all we're saying, right? Keep it simple. They're saying all the numbers are integers between -2 and 4, but including the -2 and the -4. So visually, they're saying this. So we start right on there. Everything in between. So those are all the numbers, all the integers, I should say. Right? So not every single decimal point, but all the integers between here and here.
Okay.
So we write in roster method, what would be the answer? Yeah, writing it like this.
Right before.
Yeah, 4 is going to be in there for sure, right? Doesn't matter what order. It doesn't have to be from least to greatest. I'm just doing that because I want to.
Oh, so you just, you added the numbers in between.
Yeah, just put them all the integers, right? That's the key word. Inclusively means you include the edges too. So that is the roster method. You just list the elements. Set builder notation. Right, you would say R is equal to the set X such that X is between 4 and -2. So here you actually put the inequality. See what I mean? So roster, you list the elements. Set builder, you list the, you put the inequality. So you first write the variable, and then you say what the variable is doing. That's what raw set builder does. So if they would have said all the integers above 5, you would say x such that x is greater than 5. That's it. That makes sense? Okay. Let me bring up the workbook up here. I'll put that back in a second. I think I might have downloaded it already, though. Now I think about it. Yeah, there it is. Okay. Let's go ahead and share the whole screen. That's fine. Through 4,
45.
45. Oh, there it is. Cool. So we don't have to write all these sentences. Let's just go through it together. You determine which collections. You guys read that? Determine which collections are not sets. The collection of former mayors of San Antonio. Is that technically a set? Yeah, I mean, you could put all their names in a set, right? And just list them. Why not? 3B, the collection of 5 best restaurants in San Antonio. Is that a set? Yeah, I think so too. I mean, we're just that we have all 5 in the set. And we'd call the set the top 5 restaurants. Why not? Guess it'd be Mr. Fiesel's 5 best set. I mean, I suppose it could be subjective.
Just because we're looking at the next one.
3C collection of Ivy Taylor's 5 best restaurants.
Let's say number 2 and that's the 3,
Oh, I see.
right? 'Cause
I'm making an assumption that it's that you know that's a fact, right? Is it a fact that? But no, it's not, right? So that's a good point. If you have 5 restaurants, like who decides they're the best? Like, are they in fact the best? So
if it was just restaurants, like that would have been-
yeah, so 3B, so he's right. 3B is not a set because it has to be an opinion. Like on this one, 3C, since it's this guy's opinion, then sure. I mean, that's what he said, no matter what, but this doesn't say who said that. It's just, we can't really for sure say those are the 5 best restaurants. So yeah, I agree. So 3B is not a set. 3A, this is not an opinion, so it's fine. Their former mayors are come and gone. 3D, the collection of young students attending St. Philip's. Like, well, I'm making the assumption they're talking about right now. Then sure, right? It's just a bunch of students in there. Let's see, collection of students 40 or over. The term young, though, what does that mean?
Yeah, well, that's obviously, that's not the other one. I was like, so what's young to them? 39?
Yeah, I'm like,
Because I'm like 40 and over. It's like-
yeah, again, that's another weird opinion, right? So I guess if you can't like specifically create the elements with concrete definition, like 40 over, you know, that's a legit line that you drew, right? So this will have exact data points, certain set of people. Young, I don't know what that means.
I mean, it's,
But young to a 20-year-old is young, but young to a 70-year-old, it's like, or 50-year-old is young.
That's true. That's true. Yeah, like when you talk to like a teenager, they think a 30-year-old person is super old, and then you talk to a 30-year-old, they think you know, a 60-year-old is old. So
it's kind of hard to determine what's young.
yeah, it's not what's the word? It's not objective. You got those, always get those mixed up. Objective definition. But based on influence or personal feelings, tastes, or opinions. Objective, a person of their judgment, not influenced by personal feelings. Okay. So what's the difference between subjective? So it's based on an opinion. So where objective is based on fact. So we go back to that question. This is not objective, right? This one is, because you can't argue 40. That's just, it's a fact. Even though 3C is subjective in his point of view, but since he's the one saying it, that's what it is, right? That's that guy's opinion has been stated, so it's a fact that that's his opinion. But this guy, I can't create facts based on. I mean, I guess you could vote on it and ask everyone and go with the majority, but it's not like a concrete.
Yeah, the concrete evidence to support that.
Yeah, like it's not. This is what it is, right? Like for example, the states around Texas. Nobody can argue that. That's a fact. This can be argued, so I cannot create a set of elements. So I would say, yeah, 3B is not, and neither is 3D. The rest are. But you see that difference, right? At first glance, it felt like they were, but when I started really to think about it, yeah, this first one tricked me too. Like, wait a minute. I just believed that it was. They are the best, so sure. What the hell does the best mean, right?
Right.
It's just, I don't know. Just like, what does young mean?
I've been disappointed by some of those 5-star reviews on Yelp.
Mhm.
That place 5 stars, yeah.
Yeah. That's true. And then maybe over time, their quality fades. I don't know. Or they had a bad day.
People have different taste buds or different, you know.
Yeah.
experience or whatever.
That's true. Different cultures. And I think our taste buds supposedly change every 7 years. So maybe later your tastes won't be the same compared to what you used to like, or it's not exactly the same. And the stuff that I loved as a teenager, I hate now. So
Yeah, I know a lot of times I used to like all that sports stuff, and now I'm like,
yeah,
I can't, no way.
like, I don't want Harper. Man, I can't eat. I don't eat large pizza by myself anymore. But anyway, let's just move on. But does that makes sense? Like, why they're sets though?
Yeah.
Okay, so this notation right here, it means element of. So whenever you see that, they're saying 3 is an element of this set. Is that true? Is 3 inside there?
Yeah.
So you would say, yeah, sure, it's true. So whenever you see that little epsilon, lowercase epsilon symbol,
So it's just like, it's just saying, if that's the number before the element, it's saying that that number is in the set.
yeah, like if you wrote this in English, you would say 3 is inside this list of numbers, and you would tell me, yeah, sure, true. And then the next one is 5 inside that list of numbers.
No.
So now you would say false. So that's all it is. They're just using math symbols instead of English. So just need to
And what about
understand.
like the 4C, so with the dots, with the dots, would that be like it continues until it gets to 35?
Yeah, so this guy is telling you that,
Everybody, two,
yeah,
Oh,
oops.
yeah.
so 15 will be the set.
So this, they don't list all of them because there's quite a few. So they imply and they hope you see the pattern. So yeah, all the odd numbers, that's true. 15 is odd, but you see that slash through it?
Yeah.
So that means 15 is not an element of that set. Is that true? Like, so that would be false because we just said 15 is in there, right?
And that was the last one. True. I guess that's slash, so 37 is not.
Yeah, there's some is not in here because it stops at 35. So yeah, this is true. So I'm gonna put a T for true. F. True. You guys, does everyone see why that is?
Yes.
Okay. Okay. So this part, they're trying to make you understand what does empty set mean. So you see that circle with a line through it? So if you see that symbol by itself, you would say, yes, that is empty. So let me write this down real quick. So the following symbol is the empty set symbol. So if a set is empty or contains no elements, you would say this, okay? For example, what's a good example here? Let's say I call the set A equal to this. There's nothing in there. So you would say A is empty.
And that's how you put it.
Yeah, so, but it has to be empty. If you would have said that A contains the empty set, you would say A is not empty because it contains the empty set, which is kind of weird. Think about it, like, okay, it's empty, but it contains the empty. Shouldn't it be empty? I'm like, no, because it contains the empty.
The
So
empty
the
is in the
empty
empty.
premises.
So super weird. So it has to be complete, literally
So like on
empty.
the, on the workbook, so number 5C would be empty.
Let's see. Where's the button? 5C, that is the one you would say, yeah, that's empty. For sure. 5A contains the element 0, so it's not empty. So I'm gonna put the letter N for not empty.
But then you said 5B is not empty. Right?
Nope,
Because
yeah,
that's
not.
empty symbol in the empty spot.
Exactly.
Okay.
So this one is, yes, it is empty. This is not even a set. So how would I even answer the question, right? This is the number 0. So no, because that makes no sense. It's not a set. 5E, so whenever you see impossible situations and that creates a set that is empty, right? For example, X, such that X is a flying pig, and well, there no flying pigs exist, so that set would be empty, right? So yeah, that is empty. Now, 5F, X is greater than 8.
It's not because it has numbers.
Well, let's think of the situation. Is it possible? Can you be above 8 and below 2 at the same time?
Actually, no, it's impossible.
So yeah, it would be empty, right? So yes, which of the following says empty? This is empty. Putting white for yes, empty. Hope that's clear. And this is just saying empty. 5G, I gotta admit, I don't know what they're saying there. I would say there's a symbol for the empty set. So if they're giving me the symbol, I want to say yes. Yeah, should be fine. Anyway, that makes sense what empty means. So it can't be above 8 or and below 2. So that word and means it has to happen at the same time. They would have said or, you would have said, yeah, sure, that's not empty because that can happen, right? So or and
It has to happen at the same time.
yeah, and implies both have to be true. Or as long as one of them is true for or,
Mhm.
then you're good, right? Like logically it would be true. If you would have said something like, I don't know, like today, I went to work or I stayed home. I'm like, as long as I do one of them, I didn't lie, right?
Yeah.
But if I said I did both, then that's false. That doesn't make sense.
Right, I had to go work and stay home.
Yeah, exactly. I mean, I guess
Work from home.
you could nowadays, right?
Yeah,
But, or something more ridiculous would be
I went to the grocery store and, well, I mean, everything now you can do from home.
yeah, let's say I died and was alive, right? And that's not doesn't make sense either. So there's or but see something that can happen. That's because and implies both must be true. So as long as one of them is false, then
It makes it false.
makes it false. Like I don't know, can be rich and poor. I guess
What you define riches.
can have $1 billion and not have $1 billion.
Sure, in your scalp. That's what I would say.
I think in another reality, I'm probably super rich, but not in this one.
Around this
I'm also probably dead in a lot of them too.
one.
So that's silver lining. I'm alive in this one, so that's good.
Right.
Okay. Let me clear that. Okay. So far, so that's not too bad, right? Write each of the following sets in roster notation. I don't think I'm going to make you do that because I don't want to do that. Let A be the set of US states. So you would say A is equal to, and then list every single state, which we're not going to do. Let's do 6B though. Write that down. Write each set in roster notation. So all the natural numbers greater than 7. You guys, know what a natural number is?
Natural number, no. Good number.
It is a number. It's just kind of like integers, how it's a specific type. So natural is all numbers greater. It's basically like counting numbers. It's one way, a simple way to think about it. So all the numbers above 0. Some books include 0. So 0 or above would be a natural number. So like 1, 2, 3.
So it's all positive numbers. Okay.
Yeah, all whole numbers, not negative. So all natural. That's what natural means. I've read a few math books. Some argue about including zero or not. So I always say that just in case you read a weird math book and they disagree. All natural numbers greater than 7. I don't really have a strong opinion on it. They use the set B, right?
Yeah.
So B would be equal to, so this is how you'd write it. I will not include 0, I guess. 1, 2, oh wait, I messed up already. Where should I start?
The 8.
Yeah, it didn't say equal to, right? So 8, 9, 10. Then it just keeps going. So you just put a bunch of dots in there to imply that it's going to go forever, since it didn't stop at anything.
Yeah, because it's just to infinity.
Pretty much. Same thing with E. If you change this one into the other one, right? This 6C here. The E equal X such that X is an element of N. So that right there, we need to make sure you understand. That element of N. So that's telling you that X is a natural number and X is odd. So they both need to be true. So if it's a natural number, that means it has to be 1, 2, 3, 4, 5, 6, 7. But it has to also be odd. So it would be 1, 3, 5, etc. Right? So let me write the statement down. They said, oh, actually, they had it at set builder. X.
X.
Is odd, right? They said.
Is odd, yes.
Okay, so in the roster method, that would be 1, 2, 3, 5, 7. Forever.
So that's how that would be. That would be that actually. That's exactly how you write that.
So they want this because this is the roster, right? So they said put in a roster. They gave it to us in set builder to put it in the other one. Okay. Now cardinal number. What does cardinal number mean? I was thinking about these cups. You know how they use plastic to line it so that it doesn't get all gross, right? When the hot coffee hits the plastic, is it diffusing into the liquid? Am I drinking plastic? Drinking some cancer juice. Let's see here. I believe cardinal number means the order of the set or the number of elements. Let's double check. Okay. Total number of elements in it. So yeah, simple as that. So let's write that down. Before we start, I'm going to give you another notation. So note, given a set A, equal to 1, 2, 3, 4. The notation, oops, forgot to switch back. So given the set A equal to 1, 2, 3, 4, the notation n of A means the number of elements in A. Also, the cardinal number of A is equal to the number of elements in A. So if they ask for cardinal, is the same thing. So how much stuff is in there? So in that first one, what would be the number of elements in A?
Oh.
7A here.
One would be a 1, 2, I mean,
So you got, so it's only referring to the number of unique elements. If you repeat yourself, you don't count it. So see how they have one
one,
twice? Like that's only one element. It's kind of like if you said, if you created a list or a set for all the people in this class and you put the same guy 20 times, like, that's not different people,
right,
right? So you don't count that. So we only have 1, 2, 3, 5, 8. So there's only 5 elements. So 7A, let me write this down. A is equal to 1, 1, 2, 3, 5, 8. So cardinal number is equal to the number of elements in A, which is 1, 2, 3, 4, 5. That's it. Any question on that? Is that clear or no? Okay. So the next one. What's the cardinal number of a set that is empty?
what's the what?
Cardinal number for a set that is empty. Well, I mean, cardinal number means how many elements are in there. So if it's empty,
That's infinite.
well, it'd be 0. There's nothing in there, right? Because a cardinal refers to how many things are there. If there's nothing, then there's nothing. Yeah. So this one would be 0. 0. 5. What about this guy? Number 7C, x such that x is a natural number. So 1, 2, 3, 4, 5, 6, 7, all the way to infinity, but must also be less than 7.
That's true.
It is true. So it does contain elements, right?
Mhm.
But how many?
So I have to go to 7.
Yeah, so everything below 7, that is natural.
From these. Depending on what you want.
Yeah, I'm wondering if this book counts it. I guess we'll see in the homework. They'll tell you. Right?
All right.
If they include it, then it should be 0, 1, 2, 3, 4, 5, 6. So these 7 elements. If they don't, then you just remove 1. I feel like they might. I need to check. But anyway, that's not something that's a big deal. Yeah, I'm gonna say 7. But do you see what cardinal means, though, right? It's just how much things are in there. That's what matters. What about 7D? That one's trying to trick you a little bit.
Whoa. It's not a.
It's not empty, right? Contains an element.
Say 1.
It contains 1 element, an empty set. Sets can contain other sets. So yeah, that's fine. You can have a set of sets, I guess, which is weird. But anyway, that's all cardinal means is how many elements. Nothing crazy. Just don't let them mess with your head. Okay. So now this question of infinite or finite. So you have to figure out, okay, does it go on forever or is it a set number? For example, 8a right here. This a little bit.
So like when AA, it would have a number. It would be-
Yeah, it doesn't go on forever, right? There's only so many states. So this for sure will be finite. So I'll put F. And then this guy, does this go forever? Z such that Z is bigger than 9 and Z is less than 1.
Yeah. No. Bigger, yes. Bigger than 9, less than 1. Negative, infinity.
It has to be both at the same time. Though. It's and. Can that happen?
No.
Can it be above 9 and below 1? So the set would be empty. So it's not infinite. It's empty. I would consider that finite. If you consider nothingness finite, I think that's fine. 8c. So it's a natural number and it's bigger than 7. So yeah, it just keeps going forever, right? So that's infinite for sure. Okay. Y such that y is an integer. Well, integers are pretty big, just keeps going, right? So that's going to be infinite. Yeah, I should put INF instead. Anyway, does that make sense how you can tell? So now here we're going to talk about equivalency. W is the set that contains X elements such that X is a day of the week. F is equal to the set that contains X such that X is a month with exactly 31 days. Are those equivalent?
Like a month, like themselves, so like a month, every month would be.
Yeah, like I know,
I want the months, I could say, yeah, because you could, certain months that have certain days that have.
what does equivalent mean? Let's check out this guy right here. The next question. Determine if they're equivalent, and then it says determine if they're equal. So it means they're different. It means different things. So we have to understand what the heck is equivalent sets. And what is equal sets? So equal means they have to be exactly the same, right? We're pretty sure we understand equal. Equivalent though, when it comes to sets, I believe it means they have to have the same cardinality, same number of elements. Let's double check. There's two. So two sets A and B are said to be equivalent if they have the same cardinality, meaning same number of elements. So we can say two sets are equivalent to each other if the number of elements in both sets is equal. That is not necessary. It is not necessary that they have the same elements or that they are subsets of each other. So as long as they have same cardinality, we say equivalent. So go back to this question here. Close this stuff. So how many elements does a W contain?
7.
7 for sure, right? And F?
Well, oh, no. I don't know. I don't even know how many months.
Yeah, I don't know either, actually. How many months have 31 days? So if it's also 7, then
January, March, May, July, August, October, December. 7.
7. So we would say the number in W is equal to 7, number in F is equal to 7. So yes, equivalent.
Okay.
So let's write it down. Example 9. W, X such that X is a day of the week. Okay. Then we said F, writing the exact same thing down real quick, is a month with 31 days. So what you would say is the number of elements in W, or the cardinality, is equal to 7. The number of elements in F is also 7. So since the number in W equals a number in F, then W and F are equivalent. That's all you gotta do. Does that make sense? So be careful with in math, equivalent and equal are different. Crazy. So number 10, X is a planet in our solar system. Are we counting Pluto? Guess not, maybe.
Technically, no.
So how many planets, how many planets in our solar system? 8, and that's without Pluto.
Without-
X is a current US coin that has value than less than $1. I assume current means we do not include the 50-cent piece.
What's the dollar?
Is it current?
Yeah.
Okay, so we have what? Penny, nickel, dime, quarter, 50 cent. There, and we have 8 planets, right? Whether or not we include Pluto, it's not going to be 5. So, number 10. Right. These are not equivalent because this has 8, this has 5 or so. No matter what, how we define, even if we include the 50 cent or not, or Pluto or not, they will not be equal. They will not have the equal amount of elements. Okay. Anyway,
It's crazy how Pluto, growing up, Pluto was a planet.
Yeah.
All of a sudden, it's like gone.
yeah, they changed the definition of planet, I guess. I think that's what it was, right? Yeah, it's not that, wasn't that big, I guess.
It's not round enough, but it doesn't do something. It doesn't have enough of gravity to attract objects to.
I see. Oh, well.
I don't know if you guys ever seen it. It's an old show. Not too old. Psych.
Oh, yeah, I remember that. I saw a few episodes here and
I
there.
like the show that the main character,
Hmm.
James Rodriguez, he's actually from here.
Oh, yeah,
San Antonio. Yeah.
that's cool.
So in the well, his partner in the show, his pickup line, he's a real smart guy. So his pickup line is always going. You don't have to do it. So that's what reminded me. We were all talking about Pluto. It's reminded me of that.
That's funny. Yeah, we were all mad about it. They're so mad about it.
Yeah, I understand.
It's like, yeah, it's
As
just,
long as Earth is still a planet, we're
yeah,
good.
like, just a definition, man. It's whatever. It's like if we change what even means, then they're not even anymore. All right, example 11. I think we're almost out of time. Let's see. So notice how they repeated themselves a bunch of times on part A. So how many elements does A actually have?
4.
0, 1, 2, 3, 4. Yeah, 5 elements. And B also have 5. So these are for sure equivalent when they're also the same set. So they're also equal. So yeah, these are both 12. All the numbers between 7 and 10. But this one includes 7, this one does not. This one includes 10, and this one does not. So they will have the same number, but they won't be exactly the same. So let's write this one down. Determine if the following, I'll switch in a second. Or equivalent. Equal. Okay, so C is equal to X such that X is a natural number and between 7 and 10. But including 7. Okay. D was the same thing, but they did not include 7, they included 10. So let's write down the elements so we can see it. So C will have 7, 8, 9. That's it, right?
Mhm.
D will contain 8, 9, 10. So the number of elements in C is equal to the number of elements in D because they both have 3. They are equivalent. But they're not equal, right? Sorry. They are not equal because they don't have the exact same elements. They are only equivalent, right? Any questions on that? Do you guys see the difference between equivalent and equal, right?
I agree with the equal actually have to be the same numbers, right?
They're exactly the same.
Exactly the same, equal and the equivalent, it's just at least it has the same amount.
Right. So like these turn out to be equal because they have the same elements. Anyway, so that's 5.1. So that's our intro to sets. So hopefully you know what a set is. You know what a cardinal number is. You know what equivalent means and equal. That was the main ideas today. And I guess the empty set. All right, we'll do 5.2 next time. And probably 5.3. I would try to catch up on your homework and get that test out of the way.
Yeah, that's my, I got a lot of homework this weekend.
Yeah, catch up this weekend, man. It's good. It's gonna be cold anyway. It's gonna be ugly and cold outside anyway.
I ain't really, look at you, son, I ain't really doing nothing, so I'm gonna do nothing homework.